Now, let's talk about something very important. So far, we've been using L'Hopital's rule to solve limits, but it's just as important to know when we're not allowed to use it. Here's the key idea. You cannot use the L'Hopital's rule if the limit is not in one of these two forms, 0 over 0 or infinity over infinity. If you don't have one of these indeterminate forms, then L'Hopital's rule does not apply. Let's look at an example. We want to evaluate the limit as x approaches 1 of x squared plus 5 over 3x plus 4. And we're asked to show that we cannot use the L'Hopital's rule here. First, plug in x equals 1 into the numerator. So we get 1 squared plus 5, which is 6. Now, plug in x equals 1 into the denominator. So we get 3 times 1 plus 4, which is 7. So the limit becomes 6 over 7. This is a real number. It's not 0 over 0, and it's not infinity over infinity. So the conclusion is we cannot use L'Hopital's rule here because the limit is not an indeterminate form. So always check the form first. If direct substitution gives you a real number, you are already done. There's no need for L'Hopital's rule. Now, let's move on to something new. So far, we've focused on 0 over 0 and infinity over infinity. But there are other types of indeterminate forms that can show up. Some common ones are 0 times infinity, infinity minus infinity, 1 to the power of infinity, infinity to the power of 0, and 0 to the power of 0. These are all considered indeterminate forms because we cannot evaluate them directly. Even though these are all indeterminate, we cannot apply L'Hopital's rule right away. We first need to rewrite them. Here are the strategies. If you have 0 times infinity, rewrite it as a fraction. If you have infinity minus infinity, combine everything into one fraction. And if you have one of these forms, you should use logarithms. So the big idea here is L'Hopital's rule is powerful, but it only works after we get the limit into the right form. All of these forms must be written so that they become infinity over infinity or 0 over 0. Once we reach one of these forms, then we can apply L'Hopital's rule. Alright, in the next part, we'll practice rewriting these expressions step by step so we can apply L'Hopital's rule correctly.